All right, there's one more property we need to explore, and we're going to use it to solve some kind of simple exponential equations. So, the property I'm talking about is called the one-to-one property, and it may not seem very special at first. So, most exponentials have a property like this, where if I say that 2 to the something equals 8, there's only going to be one solution to this. There's only one exponent that matches up with one result. And there's only one result that matches up with one exponent. So, like in this case, this has got to be 3. And there's no other value that's going to give me this. And vice versa. Um, if this is a certain value, there's only going to be one value here. So that means it's one-to-one. Now, something to keep in mind, not that this is going to come up on your homework, it doesn't apply if the base is any of these. Hopefully you would see why, because these would not have that one-to-one property because there's multiple exponents that'll do it. But anything other than 1, 0, and -1, you have this nice little property that says only one guy is going to find me that solution, okay? Only one exponent. Now, what that does is, let's say that there's a scenario where you say that this is true, okay? Same base, but different exponents here, or at least different expressions used for the exponents, but these exponentials are equal. What that means is these are both equal to the same value. Well, what did our one-to-one property say? It says there's only one way to get this value. There's only one exponent that'll do that for us. What does that mean about these exponents? It means they have to be the same. So if these are true, okay, if these guys are equal, then their exponents have to be equal. And we can use that to simplify a lot of exponential equations. So again, if the bases are the same and the exponents are these different expressions, we can set those expressions equal, as long as our bases aren't 1, 0, or -1. All right? So let's look over here. This would be the simplest problem that I could give you. I say, okay, 3 to the x equals 3 to the 4th. Well, if the bases are the same, we know the exponents have to be the same. So I can rewrite this to say, oh, that implies that x equals 4. Boom, we solved it. Or something like this. I say, okay, my bases are the same, but I have these different expressions for the exponents. Well, I can go ahead and say that x minus 5 equals 2x minus 6. And now it's just this easy linear equation. -5 equals x minus 7 plus 7 is 2. Okay? So if I plug in 2 here, you'll see that both of those give me -3 for my exponent. What about this guy? Mr. McClung, you said the bases had to be the same. Well, it's true. Okay, so we have to do a little bit of work here, but not too much. Is there a relationship between 7 and 49 dealing with exponents? 49 is 7 squared. Now, some of y'all, like the mental math is really strong and that comes real easy to you, but if not, that's why I gave you the little cheat sheet to help you remember some basic ones that you can hold on to. So I'm going to rewrite 49 in terms of 7. So this is 7 squared. Now we need to use that property that we learned before. If you're taking an exponent of an exponential, you can multiply these. And all of a sudden, we're back to that same form that we had before, where we've got the same base, and we can set the exponents equal to each other. So plus 3 plus 4x. So x is going to be 3/4. All right, let's do one more. All right, this is about as tricky as things are going to get for you. Oh my goodness, 1/2 and 8. Do those have anything to do with each other? Well, they do. Okay. But what could be our common base here? Well, probably the common base that I would pick would be 2. Hopefully you can see that 8 is 2 to the third. So I'll substitute 2 to the third for 8. 1/2. Oh, remember how negative exponents do the reciprocal? So that's 2 to the -1, and then x plus 3. Well, what do we do with these? We multiply. So this is going to be 2 to the -x minus 3 equals 2 to the 9th. And now we're in that beautiful form where we can use our one-to-one property. We can say, oh yeah, these have to be the same. So plus 3 divided by -1, we get -12. All right, so not every problem is going to be of this form where we can do it. On your homework today, we're starting with some easier ones. There's going to be some exponential equations that are harder that we're going to have to use logarithms on, but those are going to come a little bit later. We're just kind of warming up, getting ourselves accustomed to exponents.